All right, so next we're just going to work through some examples. So remember, as we are simplifying, if we can't simplify the form that it's in, we're going to switch forms and try to use those rules to simplify instead. So I want you to pause the video and work through these 8 examples to see if you can simplify them correctly. All right, so on 1, we're going to switch forms. So this really means the square root of 64, which is 8 for that first answer. On our second example, since I have the same base, that means that we are allowed to add our exponents together. So I'm taking 1/2 plus 1/2. So I already have the same base, so that would be 2 over 2, which would then simplify to be 1. So this is x to that first power for that. Now another way that you could work through this, if you did switch forms, we are taking the square root of x times the square root of x. And we didn't explicitly talk about how to multiply radicals, but our rule is whenever we multiply or divide, the roots have to be exactly the same, and then we would multiply what's underneath together and then what's in front together. So this would really mean the square root of x squared. And then according to our radical rules, we would divide. So 2 divided by 2 gives me 1. So then this would just simplify to be x. So this is another way to work through that same type of problem. Now on that next one, we can't simplify in the form that it's in, so we do need to switch forms. So this is the square root of 3 times the square root of 8. And then because we have the same radical, we're just multiplying what's underneath together. So this would be the square root of 24, and then we would work through simplifying that radical. So a perfect square that divides into 24 would be 4, so 4 times 6. Square root of 4 is 2, and then 6 stays underneath that radical. Now the reason why we can't just add these together is because they don't have the same base. Okay, so that's why I switched forms like this. Now another way to work through this one, based on the exponent. So because the exponent is the same, we would be allowed to think of this as 3 times 8 in parentheses to the 1/2. And the reason why we're allowed to do that is because when we multiply and we have a group to an exponent, we're distributing this to each of those. So I'm just kind of factoring it out to look like this. So then this would be the same thing as 24 to the 1/2, and then we would switch forms to this and then work through simplifying. Okay. Now again, we're allowed to do this when the exponent is exactly the same. So if it's not exactly the same, then we're not allowed to apply this rule. Okay. All right, on our next one. So bases are the same, which means that we need to add our exponents together. So we are taking 2/3 plus 1/4. So if you want, you can do that on your calculator. I'm going to work through it by hand. So we're adding, which means that we need a common denominator. So our common denominator would be 12. So I'm going to have to multiply the numerator and denominator by 4. And then on the second one, we are doing that same thing, but by 3 to get that common denominator of 12. So this will become 8 over 12 plus 3 over 12. So when I add, we're adding the top parts together, so 11, and then the denominator stays the same. So this would be x to the 11/12. And we can leave our answer just like that, or if you really wanted to, if we switch forms, this would be the 12th root of x to the 11. So these answers mean the same thing, but I would just leave it like this. All right, number 5. So we are going to want to switch forms because we can't do anything since our roots are different. So this really means x to the 3/4 over x to the 2/8. Now, since we switched forms and we're dealing with this fraction, we're always allowed to simplify fractions. So this is going to be my next step. So this will become x to the 3/4 over x to the 1/4. Now as I look here, we have the same base. So since we're dividing, that means that we are subtracting. Now when we are dealing with these fractional exponents, it's always better to take the top one minus the bottom one, and then we can write it as x to whatever we get, and then if we have a negative, we'll deal with that later. So again, right now I'm taking 3/4 minus 1/4. So denominators are the same, so this would become 2/4, which would then reduce to 1/2. So that means that x to the 1/2 is my simplified answer. Or if I wanted to, I could just write it as the square root of x, since that means the same thing. Okay. All right, number 6. So I can't simplify in the form that it's in, so I'm going to switch forms. So this is asking me to do the 5th root of 32 to the -3. Now, because 32 is a perfect 5th, I'm going to put that -3 exponent on the outside. So next I'm going to deal with this. So 5th root of 32 is 2 to that -3. And then because I have that negative exponent, that means I need to move that down to the denominator. So this will become 1 over 2 to the +3, which then, if I simplify, will be 1/8 as my final answer. All right, on 7, multiplying, but our roots are not the same. So I can't just take x times x. So I have to switch forms. So we have x to the 1/2 times x to the 1/4. Bases are the same, which means that we are adding. So for the exponents, I have to take 1/2 plus 1/4. So I need that common denominator, which is 4. So I'm going to have to multiply that first fraction by 2 to the numerator and the denominator. So this will become 2 over 4 plus 1/4, which is 3/4. So that's the exponent on my variable. So my simplified answer will be x to the 3/4. Or again, if you want to write it in radical form, we would say that this is the 4th root of x cubed. All right, and our last example, so we have to be careful paying attention to that formatting. This really means -1 times 16 to the 3/4. Okay? So when I switch forms, the positive 16 is what goes in the radical. So this is really -1 times the 4th root of 16 and then cubed. Now because I can take the 4th root of 16, I'm going to put that cube on the outside. If I couldn't take the 4th root of it, then I would put it on the inside. So the 4th root of 16 is 2, and then I would have to cube that, and again that -1 is still in front being multiplied. So 2 cubed is 8, and then I would take that times -1, so -8 would be my simplified answer. Okay. And remember, when we are dealing with negatives, only a negative exponent, so like here, is when we move something to the opposite side of a fraction. If I have a negative number, then that has to stay where it's at. That's not going to change the position of it in a fraction. All right, so we're going to keep going. So we just have some more examples. So again, I would like you to go ahead and pause the video and work through these next set of examples to simplify them. All right, on number 9, since we have a power to a power, this is our multiplication one. So we are taking 3/4 times 2/5. So when we multiply, we go straight across. So this will be 6 over 20. And then I can simplify that since those are both divisible by 2. So this will be 3 over 10. So I will have y to the 3/10 as the final answer. Or again, you can write it as the 10th root of y cubed, since that would mean the same thing. Okay. Here, same base. That tells us to subtract our exponents. So we always take the top one minus the bottom one, and then we'll deal with the negative if there is one. So we're taking 3 over 2 minus 2/3. So since we are subtracting, we will need that common denominator. And our common denominator is 6. So to get that, I will need to multiply that first fraction by 3 and the second one by 2. So this will be 9 over 6 minus 4 over 6, which gives me 5 over 6. So my simplified answer is going to be x to the 5/6. Or again, if you really want to write it as a radical, this would be the 6th root of x to the 5th. All right, 11. So here I have the same base, so I am allowed to subtract those exponents together. Now the 5 is just going to kind of hang out for a minute while I deal with the variables. So we are doing 1/4 minus 3, and I'm going to put that over 1. So we're going to need that common denominator, which is 4. So we'll have to multiply that second part by 4. So I will have 1/4 minus 12/4, which gives me negative 11/4. Okay. So that means then I will have 5 and then x to the negative 11/4. Now I'm not supposed to have that negative exponent, so this is where I'm going to move this down to the denominator. So I'm going to have 5 over x to the 11/4, and I'm going to leave it just like that. All right, on 12. So remember, when we have a group to a negative exponent, it's usually easiest to start by making this positive. And to make it positive, we're going to flip this fraction around. So this will become 81y over 16x to the negative 8, and then to the positive 1/4 power. Okay. Now if we want, we can deal with this first. So if I want, I can move x up to the numerator to make that positive. So then this would become 81x to the 8th y over 16, and then to that 1/4 power. Okay. Now I can't really do anything else to simplify in this form, so what I'm going to do is I'm going to switch forms. So I'm really doing the 4th root of 81x to the 8th y over the 4th root of 16. So when we do that, we're just taking the 4th root of the top part of the fraction and then the 4th root of the bottom part of the fraction. So if I'm trying to simplify this, 81 is a perfect 4th, so that will become 3. And then 8 divided by 4 is 2, so I'm going to have an x squared. And then I can't simplify the y part, so that's still going to be the 4th root of y. And then over 4th root of 16 will simplify down to a 2. And then there's nothing else that I can do to simplify, so that's going to be my final answer for that problem. So on the next one, so there's a couple different approaches that we could do. I can first deal with this negative exponent, or I can switch forms and then deal with it. So the order that you choose to do that in doesn't matter. So what I'm going to do is I'm just going to leave it for right now, and I'm going to switch forms. So I'm going to have to do the cubed root of negative 8 xy cubed z to the negative 6. And then I'm going to put my power on the outside. Okay, so I'm going to deal with taking the cubed root of everything that I can, and then I'm going to deal with this power. Okay. So the cubed root of negative 8 will be negative 2, so that's going to come out of our radical. I can't do anything to simplify the x, so that's going to stay inside. 3 divided by 3 will be a 1, so I'll have y to the first. Negative 6 divided by 3 will be negative 2, so z to the negative 2, and then I will still have the cubed root of x, still in parentheses, squared. Okay. Now because this is all multiplication, that means that I'm allowed just to square each part individually. Okay. So as I do that, since it's in a parenthesis, negative 2 squared, so negative 2 times itself, will become a positive 4 because it's in the parenthesis. I will have y squared z to the negative 4. So again, I'm taking negative 2 times 2. And then when I square this, I am squaring the exponent here. So I'm distributing it to what's inside. So this will become the cubed root of x squared. Okay. And then my last step is going to be to deal with that negative exponent. So again, thinking of this as a fraction and moving just that z term down to the denominator. So this will be 4y squared cubed root of x squared all over z to the 4th. And then that last example, so because it's a negative, I want to start by making that a positive. So I'm thinking of this as over 1. So I'm going to start by flipping that fraction over to force this to become positive. So I will have 1 over negative 27 x to the negative 9 z to the 6th, and now all of that to the positive 1/3. Okay. So next I'm going to switch forms. So that means I'm doing the cubed root of 1 over the cubed root of negative 27 x to the negative 9 z to the 6th. So the cubed root of 1 is just 1. Cubed root of negative 27 is going to be negative 3. Negative 9 divided by 3 is negative 3, so this will be x to the negative 3rd. 6 divided by 3 is 2, so z squared. And then I do need to deal with this negative exponent by moving it up to the numerator. And at the same time, we always simplify our negative sign up to the top part. So this will become negative 1x to the positive 3 over 3z squared for that final simplified answer. So there's lots of little rules when we are simplifying these. So there's not just a nice set. A lot of times there's more than one correct way to work through things. For example, on 14, I could have started by moving my x down and then doing the cubed root to everything. I still would have come up with that same final answer. So it's okay if your work doesn't look exactly like mine when you're working through these, as long as you're getting that same final answer. And again, if you can't switch it or simplify it when it's in one form, we're going to switch forms and try to use those rules to simplify instead. And that's going to conclude this section.